my group worksheet?
Oh, yeah, I didn't see it for some reason. Here, you can have this for now.
Okay.
All right. Oh, man. All right. So being out in the parking lot now, it's so far away to everything in the world. I ran out of enough paper to make enough copies of answer keepers, so we're just going to do this right now. Get it on the record. What's happening? Here, quick. Give me that guy. Give me that guy. All right, guys, so I wanted to start this off. I didn't mean to put this here to trick you or something. These are the same problem, right? That was the whole point. Because what the hell does X matter? What does X mean? Unknown. Yeah, it's an unknown thing. And do you know what the square root of 5 is? No, you don't. Don't tell me you do, because you don't. Damn, Jeff, that's me. You can estimate it. You can tell me what your calculator says. You're both wrong. It's just an ugly, forever-ending, never-ending thing, right? So both of these are the same problem. I got one thing I don't know, plus two things, plus three things, so of course I got 6 things I don't know. So here I got one thing I don't know, plus 2 more of those things, plus 3 more of those things, so I got 6 things I don't know. That's not the 6th root. That is 6 square root of 5s. Just like this is 6 x's. I love it. Not a big deal. Same thing here. My God, don't put 4 as the answer. You guys see what somebody puts 4 there thinks? If somebody put 4 here, what do you think they think? They say equals 4. Looks fantastic. Because I killed the x, Jeff. No, you didn't. You can't kill freaking multiplication with subtraction. Yeah, I got 4 x's minus x is how many x's? 3x. 4 of these minus 1 of these is 3 of these. I like it. So that's 3 square root of 6. So I can get a little evil about where that 3 is, especially when it's handwritten. So that's why I don't handwrite. Oh my God, can you imagine if I handwrote tests? Good Lord. That'd be cruel and unusual. All right, so that's all just the idea of like terms. Making you realize it's the same idea it's always been. So here, what can I combine? Yeah, the root 5s. So how many root 5s do I got? Negative 3 of them. And then how many root 7s do I have? Negative 2 of them. I like it. And why can't I go any further? Because they're not like terms, and I can't simplify either radical. I can't make them be like terms because they won't. That's the simplest they could be. So please, dear God, notice. That's why I put this here. You just did something where you stopped. You had a natural place to stop. So here, the beginning is the same as the place where I stopped because there's no like terms and I can't simplify any radicals. There's no way to make like terms. So that's it. There's just no like terms. You're done. Already simplified, can't do anything. Don't just leave it blank though, it makes you worry. But what do I do? What's the difference between number 4 and number 5 then? Number 5, I could do something. That doesn't matter. That doesn't matter within it. I really want you to realize, if this would have been square root of 7 plus square root of 2, I still couldn't do anything here because they're not like terms. Here they're not like terms, but each one of them I can break up. So this would be good, and this will be square root of 4 is 2. Square root of 2 is, I don't know. Square root of 9 is 3. Square root of 2 is, I don't know. So I got 5 total things I don't know. I like it. there are certain processes throughout all of math that the process doesn't change. Just how I carry out the steps of the process might change. Right? What about this guy? Read this off for me. What's it say? 4 rad 12. So what's the operation there? Multiplication. So anything that you take out, and I don't like that phrase, we're not taking anything out of the radical. You can't. We are doing the radical of the part we can. So anything that comes out is going to multiply by the 4. Why? Because that's what the 4 is doing. It's multiplying by all the stuff. So how do I break up rad 12? And how do I break up rad 75? So rad 4 is
2.
times 4 is 8.
5.
5. 3. Rad 3. I like it. Cool. So they act like variables to a certain degree, but they are numbers. So there are situations where I can do more because they're not totally unknown. They're just sort of unknown. I don't know what the square root of 8 is, but there's stuff I can do to it to simplify it a little bit. So what about number 7? This isn't as nearly as bad as it looks. Square root of 25 is? Square root of x is? I don't know. Square root of 36 is? 6. Square root of x is? I don't know. Yeah, 11. Rad x. I like it. Square root of x. Kick ass. Please don't think square root of x equals x. That's a neat trick. Therefore, the square root does nothing, so why would we have made it up? And you're all like, I don't know. You're all goofy. All right. Well, we make things up because they have meaning. They mean something. What about, now here, this is just the same idea, but with a cube root. So I'm not going to break this up as 4 times 4, so it's going to help me. I'm going to break it up as, cube root of 8. Because cube root of 8 I can do. Plus 3, what am I going to do with 54?
9.
Why is 27 a good number? Because it's 3 cubed. Yeah, it's a cube root, so I need something that's cubed. I need something I can do the cube root of. Is this all coming back? I know it's been a while. Here I was sitting there like, eventually something's going to sound familiar. Hopefully not too many of you in that boat. So here I get 2. Cube root of 2 plus cube root of 27 is times 3 is 9. Cube root of 2 is 11. Cube root of 2. I like it. Okay. And then this guy is kind of like the reverse of what we're just doing. Instead of pulling them apart, we're putting them back together. So this would be 15. Square root of 10. Minus 3. Rad 35. I like it. And there's not a dang thing I can do with that. I already know what they're made of. They're made of nothing useful. Poor little guys. And they're not like turps. So I'm done. What do I mean nothing useful? There's not 2 of something in either one of them. I know what went into them. I'm not going to waste time trying to make them cancel or trying to make them reduce because I already saw what went into them. This guy the same way. But some of you guys might realize the middle terms are going to cancel, so screw them. What's rad x times rad x? X minus this plus this, the middle terms cancel. Minus 5. Done. You don't put it in absolute values. That doesn't make any damn sense at all. What does x already have to be in order for this to make sense? If I didn't say anything about using complex numbers, x already has to be greater than equal to 0. I don't need an absolute value then. You're overthinking it. There's no need for it. I didn't introduce something that wasn't there. It's when I take a square root of something that I have to put absolute values or I have to do plus or minus. We'll see that pretty soon. What about this guy? Same idea as number 9, just more stuff to worry about, right? So I'm going to do this a little quickly. 15 times 2. 21 rad 6. 20 rad 10. 28 rad 15. Right, because rad 2 times rad 2 is 2. So the only thing you really do is make this a 30. So it's 30 plus 21 rad 6 minus 20 rad 10 plus 28 rad 15. It's all those parts. And your brain is going, something's got to happen, and you go, no. Ain't no like terms there. Ain't no like terms when I'm doing. Oh. All right. Any questions on that one? That was that 10-4.
Bless you. Bless you.
Any questions on that one? All right. Let's get back into where we kind of left off. I want to do a couple problems before we get back into complex numbers. Yeah. So if I had something like this, yeah. All right. I think we did plenty of these before, but it's been a week. I got a little group worksheet for the labs. It's going to involve this, hopefully, if I print out the right one. What would I do first here? Three? I like it. Square it. So this, whenever I say something like the processes we use in math don't care what's there. They don't. How do I solve an equation? I undo all the stuff that's being done to my poor variable. I get all that crap trying to tear him out of this big pile of football players and see who's got the ball. Get off of him, get off of him. So I'm trying to, somebody added to, get off of him. So they put a square root, get off of him. You know, whatever keeps it in your head. Trying to unbury that poor x dude. So what's the opposite of square rooting is squaring.
X minus 9.
And so x equals?
8.
Okay. And they can check it real quick. 10 minus 1 is 9. Rad 9 is 3 plus 2 is 5. Yay! Now, what could I do if I gave you a problem like this here? So we got that there? If I gave you a problem like this here, yeah, can't equal a negative. It's not even a complex number that would help this guy out directly. Because a square root is defined to be the positive root, so there's really no way to make this work. It's a definition problem, so there's no solution. But what's the difference? So that would be no solution. What if the problem would have been this instead? That one's no solution. What about this guy? Oh, careful. This is not a domain question. This is not a domain question. It's just a solve question. So this is a lot like, remember when I had absolute value? If I had absolute value, 5 minus 3x equals negative 2, what could we say? Right there. If I had absolute value, 5 minus 3x equals negative 2, what could I do? Do I have to do any work? Because the absolute value has to come out not negative. It has to be positive or 0. So is there any way the absolute value can equal a negative number? No. So I could do some work. Just like here, I could square both sides, couldn't I? And I could do a lot of work. I could get some answers, and they all would not work. Because right at the beginning I say, oh, there's no point to this. It's a bogus equation to begin with. Same idea here. Radicals have to come out positive. So it's bogus at the beginning. But what about this guy? Huh? You can solve it. Why? What's the main difference between these two? Oh man, today's gonna be rough for me. I like that. That's how everybody feels. Yeah, one's a square root, one's a cube root. What's the big difference between odd roots, even roots? Who's the laid back one? Who's the guy that can handle whatever? Odd roots. They're like, whatever. You want to be negative? Come on in. You want a negative answer? No problem, right? Because it maintains the sign of what's put inside of it. Even roots, no. They clam up. They got weird-ass complex shit going on. They got really bad names. Hopefully you guys were here for the video last time. It's really good. So what do I do to both sides here? Cube it. So then I'll do this side. With this side you get negative 8. Then you subtract 5, divide by negative 3, so you should end with 13/3. Bless you. Cool. All right. So it's enough of, so that's reviewing, what was that, section 10.6, I think it was. Now what we did last time, if you were not here, you desperately want to watch that video. But let's just remember one thing real quick that we did at the end last time. I to the first is I, that's crazy. And what was I again? I do be the square root of negative 1. So I to the first is I. That's amazing. Who remembers what I squared is? No. Negative 1. So let's try it. What would I times I be? Would be square root of negative 1 times square root of negative 1? No. Again, so. What's the square root of 11 times the square root of 11? 11. What's the square root of 18.26 times the square root of 18.26? 18. What's the square root of x times the square root of x? X. That's weird. But that's true. So there's a really subtle thing going on here. Do you guys see that rule? I was trying to get it in your head because it works, period. This is negative 1. Now, there is something very subtle. Oh, you guys are like, math is hard. Don't give me this subtle shit, please. But, all right. Some of the rules we've learned so far have been for real numbers. There is one specific rule does not work when you have complex numbers come into play. And that is the interchange. So normally, let me just try this out. Normally we'd say these are the same, wouldn't we? These are the same thing, right? In fact, that's sort of how I said, how can I rewrite x to the 2/3? I can either write that as cube root of x squared or cube root of x squared, right? Let me stop there for a second. Does that sound familiar? Remember that? What's on the bottom? Roots. What's on the top? Powers, right? Root power. Like, where's the power got to be? Either way. But here's when you start introducing imaginary numbers, you actually have to be careful. This is a specific rule that only works when you have real numbers. So well, up here, right there, this is the square root of negative 1 squared. Now that is negative 1, because the square root and the square cancel. Do you guys see that? But this is not the same thing as the square root of negative 1 squared. What would this be? Oh, shit. Yeah, because what's negative 1 squared? 1. Square root of 1 is 1. These are different. So when I have an I times an I, that's going to be a negative number. Because it's squaring the square root of negative 1. You're going to get negative 1 as the answer. And I showed you a slightly different way to think about it with the rotation thing, which I know is really weird. But to be honest, it's the actual truth. There's so many things we show you that only works for lower levels of math. Once you get higher, like, okay, here's what's really happening. This is one place where I decided to just show you the real truth. I don't know if you guys remember this thing we did last time. If I multiply by a full -1, you make a full 180-degree rotation. But if I multiply half a -1, the square root of -1, I should make a half rotation, so I end up at I. And then if I do another I times I end up at -1. Now I've got 2 half rotations to make a full rotation. I love it. That's a very strange idea. Let me immediately show you. I want to go back. I had to take a little side trip because we forgot what this was, but now we know what this is. What's I squared? -1. So what's I cubed? And one more rotation. Or take I squared and multiply by another I. What's I squared?
-1.
Times I. So what's -1 times I?
-1.
I. And if you look, oh, you guys, I love it. If you look at this little picture again, there's 1, 2, 3 rotations. I'm at -I now. So how much do you have to know this picture? Not at all. If you don't like this picture, you can go, screw you, picture. I'm just trying to give you a kind of a visual way to remember these. These are what you're going to have to know. Yep. And what's I to the 4th? If I make one more rotation, where do I end up? 1. And sure enough, another way to do I to the 4th is I squared times I squared. What's I squared? -1 times -1
1.
is 1. There it is. Oh man, sick Jeff, great. Now watch this now. Oh. And some of you guys have tuned out. You're like, oh, barely need to know 7.8. What the hell do I need to know I for? Fast class. This is going to repeat now, because what did I just do on my visualization? I just started over again. So I to the 5th is going to be the same thing as I. I to the 5th would just be I to the 4th times I. It's going to be I again. I to the 6th is going to be -1 again. So forth. Yes, sir.
Số phi tuyệt y hoạt. Số tràng tuyệt.
So for example, 1, 2, 3, 4, and then again 1, 5, 6.
Yes.
Học rất.
Yes. So there's only 4 possible values that come out for I to a power. I, -1, -I, 1. And they repeat. They're cyclic is what it's called. What's the period of this cycle? Well, how long does it take it to go through a complete cycle? 4 turns. On the 5th turn, it starts over again. So, what the hell does that mean? Well, I to the 1st is I squared is -1, I cubed is -I to the 4th is 1. You have to know those 4. Now watch, this is so cool. I to the 44th power. Now watch, if I go through one circle, how many powers did I go through? 4. Let me give you that, right? 1, 2, 3, 4, right? So if I go again, how many powers will I have gone through? 8. So I start over again. Every 4th one, I start over again at 1. So I to the 44th is freaking 1, because it's 4 goes into 44. There's 11 turns I just made. So where am I going to end up? At the beginning again. I'm going to end up at 1. All you got to do is divide the power by 4 and see where you are in the cycle. If it goes in neatly, I'm at 1. If it goes in, like what's I to the 37th power? 4 goes into 37.
-I.
4 goes into 37.
-I.
4 goes into 37. 9 times with 1 left over. I love you guys. I love you guys. 1 left over, remainder 1. That means the answer is going to be this. So this is I to the 36 times I, which is 1 times I, which is I. Don't make too much out of this. It's not that bad. If you divide the power by 4, you see where you are in the cycle. Because it just keeps repeating. So I'm just kind of ripping off all the extra rotations I don't need. So I to the, what do you got, Jeff? 15th power. 4 goes into 15. 3 times with 3 left over, so it's going to be the same thing as I cubed, which you will memorize, and you'll know that I cubed is negative 1. I like it. All right, so the only reason we do this is we're going to do algebra with complex numbers, meaning I'm going to end up with I cubes and I 7th powers and all that stuff. I have to know how to simplify those. So what do I mean by that? I mean this. So every single complex number looks like this. We've already seen a bunch of complex numbers. In fact, that's the only numbers we've ever worked with are complex numbers. Because they all look like this. A plus BI. So for example, 7 minus 4I is a complex number. What's A? 7. What's B? Negative 4. There it is. Negative 4. Okay. So what about 11I? What's the real part? Let me try to say it like that now. What's the real part? No. Isn't that the imaginary part? So here the real part is 7. The imaginary part is negative 4. Real part is 0. The imaginary part is 11. So every single number we've seen before we talked about i's, and isn't it great to use Roman numerals for this? Has been one where A is a number and B is 0. There's only a real part, because we've only looked at real numbers. So real numbers are a subset of complex numbers. They are special complex numbers where B is 0. So every number you've ever used has been a complex number, just a special one where B is 0. It doesn't come off the real plane. So, the very, very basic stuff you can do with complex numbers is almost too nice to believe. So for example, adding and subtracting.
Kiki.
I can see it.
I just want to finish writing it in my own language. So what if I had this? What does your gut instinct say? Yeah, combine it like terms. Like, you guys just don't want to believe it. That's all the shit there is to it. So when I add complex numbers, I have to add their real parts and their imaginary parts together. That's nice. As you've always done that. But the imaginary parts were 0i and 0i, so you didn't even show that. It's really smart of you. So, I mean, please, dear God, realize that this just becomes a polynomial problem. Right? So if I had something like 2i minus 7 minus 3 minus 5i. What do you guys get? Yes, 2i minus 7 minus 3 plus 5i is 7i minus 10. Just don't forget that minus sign has got to go through and make this a plus here. I like it. All right, so that's nice. That's beautiful. I love it. My little time cops out there are like, you have 1 minute. Okay. So what if I had this problem instead? What's your little gut tell you to do here? Your little algebra gut? Good. Listen to that algebra gut. Do it. But I, we know now, is not just a letter. It means a specific number. There should be more you can do here than normal. But the very first step, just do it like normal. How's that like there? Is that what you guys are getting? Now, normally I would then combine the middle terms, because that's where that would normally be. So 28 minus 30. 2i. Now what is I squared though? What is I squared? Negative 1. Now people get a little happy about this and they replace I with negative 1 everywhere, and then I would be like, why the hell would we make up I? We already have negative 1. We have that idea. I need the square root of negative 1 idea. Don't make I become negative 1. That's not true. I squared is negative 1. That's the most important power to know, is I squared. So then you get 24 minus 2i plus 35, so you get 59 minus 2i. Okay. All my clock watchers will tell you it's about time. So I'll see a few of you guys in the lab here in a minute. If you didn't get something back, come up here and get it. Whew.